Hi everyone, thanks for listening to my presentations. Today I'll be talking about iodine and thyroid hormone synthesis. Briefly, it's all about the role of iodine and thyroid hormone synthesis. This is part 3 or 7. If you haven't listened to parts 1 and 2, please kindly do. Okay, let's go. Iodine could be obtained from sea salt, iodized salts, seafood, seaweed, kelp, dairy products, and vegetables. Dietary iodine. Dietary iodine is absorbed as iodide, and it is rapidly distributed in extracellular fluid. It is transported into the thyroid gland, because that is where we need it, right? And it's excreted via urine. In iodine deficiency, we will know whether it is mild, moderate, or severe based on some parameters in urine. It is mild when we could pick 50 to 99 micrograms per liter in urine, and it is moderate if it is between 20 and 49 micrograms per liter in urine. Iodine deficiency will be tied to be severe if it is less than 20 micrograms per liter in the urine. What are the effects of iodine deficiency? Number 1, fetuses and infants will have severe growth and mental retardation. There will be thyroid enlargement. Later on, we'll come across goiter in the course of this presentation, this series, and then we'll understand better. Okay? Then there will be learning disability, because it affects both somatic and brain development in children. That is why so many centers across the globe will screen for hypothyroidism in the newborn. The steps of thyroid hormone synthesis. Number 1, iodine is trapped by follicular cells, because that's very, very important for the synthesis. So iodine would then diffuse to the apex of the cells. The iodine is transported with the colloid, that is thyroglobulin. Oxidation of the inorganic iodide will take place with the help of thyroid peroxidase. Then, 2 molecules of deiodotyrosine will form T4. Of course, grade 1 will know that 2 plus 2 is equal to 4, right? Or monoiodotyrosine, that is 1, with deiodotyrosine, that is 1 plus 2, will give us T3. Step 6, by endocytosis, thyroglobulin will be taken into the follicular cells from the colon, and T4 and T3 are released into the circulatory system. Tyrosine. The rate of tyrosine or T4 production is about 80 to 100 micrograms per day, all taking place in the thyroid. T4 is degraded at the rate of 10% per day. 80% of T4 is deiodinated as 40% to T3 and 40% to reverse T3. The remaining 20% is conjugated with glucuronide and sulfate, deaminated and decarboxylated to form tetraiodothyroacetic acid, or cleaved between the 2 rings. T4 to T3. T3 is the biologically active form. T4 to T3 conversion in non-thyroid tissues is highly regulated. The process is catalyzed by T4 5-deiodinases or tyrosine 5-deiodinases, and that is predominantly taking place in the liver and the kidney. The tyrosine 5-deiodinase type 2 is found in the brain, the pituitary gland, and the skin, while tyrosine 5-deiodinase type 1 is found in the liver, kidney, and thyroid. Type 1 deiodinase will be ineffective under certain situations. Features: hypothyroidism, starvation, diabetes mellitus, anemia, propylouracil. Amiodarone. You can check my channel for a separate presentation already published on amiodarone. Glucocorticoids, you can also check my channel for that. Beta blockers, reverse T3, all in the liver, kidney, and thyroid. Type 2 deiodinase will be inactive or ineffective in fetus. Hyperthyroidism, amiodarone, all in the brain, pituitary, and skin. The activities of types 1 and 2 will be increased under certain different situations. The activities of type 1 will increase under hyperthyroidism and glucose with insulin, and of course in high caloric foods. While type 2 activities will increase in hypothyroidism. So non-thyroidal illness and medications can affect T3 production. Both T4 and T3 are bound to tyrosine binding globulin, transthyretin, that is TTR, and albumin. They form the circulating storage pool, while the unbound is free for reuptake. T3 occupies specific nuclear receptors with B1 in the brain, heart, liver, and kidney, while B2 in pituitary and hypothalamus. T4 and T3 production regulation. Thyroid-stimulating hormone from pituitary gland, particularly or specifically anterior pituitary, or the thyrotropin, that is TRH, from the hypothalamus, will regulate the thyroidal biosynthesis of T3 and T4. TSH, that is thyroid-stimulating hormone from the anterior pituitary gland, its secretion is suppressed by T4 and T3 level in the circulatory system. That is a negative feedback. Extrathyroidal conversion of T4 to T3 will be affected by certain factors. 1. Nutrition, hormones, illness-related factors, and medications. Thyroid-stimulating hormone secretion. It is stimulated by thyrotropin releasing hormone from the hypothalamus, and it is inhibited by somatostatin, dopamine, and glucocorticoids. TSH stimulates all the steps in thyroid hormone synthesis and secretion, stimulates intermediary metabolism, stimulates expression of many genes in thyroid tissue, and causes thyroid apoplasia and hypertrophy. Still on TSH, actions will be initiated by binding to specific plasma membrane receptors, and that will initiate activity of adenine cyclase. With that, there will be increased cyclic adenosine monophosphate. The cyclic adenosine monophosphate will activate several protein kinases. Still on TSH, there will be stimulation of phospholipase C activity in thyroid tissue, increased intracellular calcium ion concentration, and protein kinase C activity. With that, I've come to the end of this very presentation. The next presentation will be on thyroid hormones and actions, and that will form part 4 or 7. Please remember to share and subscribe. I appreciate it.